Alright, I found my information. I just pushed the wrong button. So, I'm coming back here. I've got my information. And from my water vapor sheet, I need to subtract 19.8 millimeters of mercury, because that is the pressure of just the water. Because I want the pressure of what's called a dry gas, just the hydrogen. So when I subtract those guys, I'm going to subtract 19.8, and I get 694.0 for my pressure of just the hydrogen gas. So 694.0, and that's going to be millimeters of mercury. So now, finally, I have a number that I can put down here. And I know that seems like a lot of work, but I can put a number here. That's my pressure of my hydrogen gas. Now I'm going to solve for V2. So I'm going to do that cross multiply and divide, and I'm going to put my V2 right up here when I do that math. So I'm going to multiply by 0.0253 times 273 divided by 760 divided by 295. So again, this is a mixture of data from different people. So you have some data that's going to be different. For you, the pressure is going to be the same for everybody. The difference in height here will be different for you and your partner. So that means that this will be different for everybody. For you and your partner, it will be the same. This will be the same because we all worked at the same temperature. So again, this temperature is for first block. In second block, we worked at a temperature of 21.5 degrees, so it was a little colder in here. And you have a different vapor pressure you'll need to subtract. Sorry about that. Little awkward silence, but at 21.5 for second block, yours will be 19.2 millimeters of mercury, according to your green sheet, instead of 19.8. So not too big of a difference, but definitely take a look at that and subtract 19.2 instead if you're in second block. So now you'll have a pressure of what you and your partner have. So if we do that math, and I do that math in liters, I get 0.021. Let's see, I have 4 sig figs, I have 4 sig figs, I have standard temperature and pressure, don't need to worry about sig figs there, and I have 4 sig figs. So 0.02138. Remember that 0 is not significant. That is not good, so I will fix that. That is liters of hydrogen. So 0.02138 liters of hydrogen. Alright, we're not there yet. This is the process. So what we're going to need to do is figure out how many liters it would be per 1 mole. We didn't make a mole, so we're going to figure out how much we did make. So I'm going to go to a new sheet. And on this new sheet, we're going to take a look at that balance equation. We have magnesium plus HCl. It's going to be 2HCl when I balance it all. Yields H2 plus MgCl2. I'm going to take an amount that Andrew Rickards gave me from second block, and his amount of magnesium that he had was 0.0198 grams of magnesium. And we're going to use that amount, so this is going to be different for different groups, to figure out how many moles of hydrogen we made. Because we're going to assume that all that magnesium reacted. So 24.31 grams per 1 mole. And then for every 1 mole of magnesium from our balanced equation, there is 1 mole of hydrogen. If I do my math, I'm going to take 0.0198 divided by 24.31. I get 0.000814 moles of hydrogen. Remember, this will be different for different people. I'm going to now take, finally, well, figure out how many liters per mole. I'm going to take the liters I got from last time, from my PV equals nRT, 0.02138 liters, divided by the amount of moles that I made of hydrogen. And when I divide those two, I'll be able to see how close I am to 22.4. With this hodgepodge of data, I got 26.25. And that is liters per mole. So we have that many liters per mole. This is where you'll figure out how close you are to 22.4. You will now figure out the percent air, because using the formula on page 45, you'll be able to figure out the percent air of what you got versus 22.4. Actually, I have one less big figure because of this 0.814, so this needs to be a 3 here, so 26.3. Don't forget to do the flow chart for your procedure, make it look pretty, and you should be able to finish up your lab at this point. Remember, that's due on Friday. Not able to stop it because I am hitting my thing.